Okay, so let's look at even at the beginning. So what's the oxidation of silver in Ag2S? So in this one, when it's the elemental form of the silver, what's the oxidation state? 0. Home run. Ag2S, it's going to be +1 because sulfur and oxygen are in the same column. Therefore, you've got that. So we talked about that second question on part B. Now, on part 2, using principles of atomic structure and Coulomb's law. So when you see that it doesn't say or, it says and. So you want to address both of those when you answer that question. So, atomic structure. So if you look, and again, this is periodic tables you're going to have. So when you find copper, if you count down 1, 2, 3, 4, there's not numbers out here, but those numbers tell you basically what the highest occupied energy level is. So if you notice, copper's here, silver's down below. So that means for copper, N is going to equal 4. That's what we call the principal quantum number. For copper, and then silver is the next one down, N is going to equal 5. So they're in the same column, but they're going to, so copper, those electrons are going to be closer than they are for silver. So when you get to this, so when you look at this equation, F equals K Q1 Q2 over D squared. So what's going to be a greater factor mathematically? The amount of charge or the distance? Distance, because that is squared. So what you need to say is, on this one, why silver has a larger atomic radius. So you need to talk about two things. Number one, silver has just a larger radius because it's in a lower column, so it is a bigger radius. The other thing is that you need to mention, because of that bigger radius, there is a smaller attractive force for those electrons that are further out because you're dividing by a bigger value of D. Okay? Makes sense. All right. Now, when you get to C, anybody have an answer on that one?
Yeah, I got that too. Yeah, 0.083.
Yeah, 0.083. I can live with that. Now, they don't generally get horribly picky about scientific or significant digits, but with this one, notice you've got all of these have like 5 digits in them. So when you write that answer, they'd probably give you credit if you wrote 0.083, but it'd be better off if you put like 0.0829 or something like that, because your data has a lot of significant digits. So when you write that answer, this is in your wheelhouse, Adam, then you need to write a lot of digits with that. So here's kind of the general rule with significant digits. If they give you a lot of precise measurements, use a lot of precise measurements or values in your answer. Okay? So keep that in mind. Now, you get to that next question. And you've got rhodium is plated, process, So this involves electroplating. And you all have seen this, okay? Like we did that demonstration with silver where I took silver nitrate and I put in the electrodes and we formed elemental silver. So this is going to require, and this is where you look at the big picture. This is going to require an input of energy. So right away, what do you know about your sign of E9? It's going to be a negative value. When you know about your sign of delta G, it's going to be a positive value. They didn't ask that specifically, but this is where little bells and whistles should go off and go, okay, hey, I see where this is going. So if you can kind of get an idea, like, okay, hey, where are we going to go with this? So they're not going to give you like the entire half reaction chart. What they will do is they will give you parts of whatever you need off of that chart. So on part 1, it says, write the balanced net ionic equation for plating out rubidium from the acidified solution. Now, there's a couple of hints that they gave you. One is a big hint where it says oxygen gas is produced. Okay? So right away, when you look at the two half reactions, what's the only way that you can produce oxygen gas? Is if you flip the second one, okay? It didn't say oxygen gas was added. It says oxygen gas was produced. Now, here's where this is going to be important later on. So you're going to flip the bottom one, and then you're going to get negative 1.23 volts, and then you've got 0.80 volts. So that combination is going to get you a negative E0 value, which is consistent with the idea that this is a non-spontaneous reaction. So on the balanced net ionic equation, you should have 4 rhodiums, 6 waters, 3 oxygens, 12 hydronium ions, and 4 rhodium atoms. Okay? Make sure that you put the charges. Don't just skip that. Put the charges down. So your E0 value, you get negative 0.43. Then on that last question, based upon your answer in part D, explain why this process requires the use of an external power source. Now, here's a little self-check. If they give you that question and you look and you have a positive E0 value, yeah, don't be afraid. It's like, whoa, retro. I have a spontaneous reaction. This is bad. So you can use that as a self-check to go back and go, hey, you know, let's talk about this. Why that answer isn't consistent. So on E is just basically a stoichiometric problem that involves a whole bunch of cells. So you got 2.8 grams of rhodium. Now, let's say you get to this problem and you have no idea what to do. There's no equation on how to solve this, nothing. But at the end of the day, what do you want in that last cell? Seconds. You know you want seconds up there, because that's the only way this works, is if in that last cell, you end up with seconds. Well, the only thing that involves time, and they were even nice, instead of saying 2 amps, they even said this is 2 coulombs per second. Right? They could have just said this is amp. They didn't. So now you got 2 coulombs here. So the question being is that how do you start with grams of rhodium and end up way over there in time? Well, what's the next conversion you're going to do?
Moles.
Moles. Okay. 102.91 grams of rhodium is 1 mole of rhodium. Okay, now what? 1 mole of rhodium is contains how many moles of electrons? 3. How do you know?
The charge was
So, number 1, you can look at the charge, okay, on the reduction chart and go, oh, those 3 electrons are involved. If they didn't give you that, they also said, oh, that's RH2SO4 3. So let's say you didn't have the reduction chart and you had to figure it out. Well, that only works if you reverse that and rhodium has a charge of 3 plus because you know sulfate is 2 minus. That's the other way that you could have figured it out. All right, so if you stop right now, what are you in? Moles of electrons. And we got to have one more step. There's one more step in between. Faraday's constant. And in 1 mole of electrons, there's 96,500 coulombs. So you do all that, you get 3,900 seconds. Okay? Cool with that. Good. Okay. Now let's kind of go old school back to this. So do the one, it's that sheet that I gave you. There's a weak acid problem. Okay? Do that one. That one should be old school. So try that weak acid problem. All right, Mara.